Welcome to my workshop. In today's video, I will try to prove to you that having a 3D printer in a workshop environment just makes sense. In my case, I'm going to be using the Elegoo Centauri Carbon 2. So the first project I want to show you, it's a zero clearance insert for my table saw. Now in this case is the Evolution TBLX, so it's the new model from Evolution. It's a fantastic saw and the throat plate is actually made out of metal. It's really good quality, it doesn't bend, it doesn't wobble, it's great. And in this case you can actually buy the zero clearance plate from Evolution, but it's kind of expensive and not many other makes actually offer that feature, the zero clearance plate. In my case, I've actually decided to make my own version from plywood. Now I've made a video on it, which I'm going to link down below in the description of this video, and there should be a QR code next to me. If you're watching this on a TV, just scan this QR code with your phone and it will take you to the video. It's a very simple thing. You just put it like so on the back, glue it in place with some hot glue or double-sided tape, and it just works. So simple, but it works. However, you know, it takes time to make it. So I thought to myself, why not 3D print this? And to be fair, depending on what blade you use, you're going to need several of them, as I do have different blades with different size of curves. If you ever used a laptop or a PC to do anything, I think you will be absolutely fine to use Tinkercad. It's absolutely free and it's web-based, so you don't even have to install anything. You just sign in with an email and Bob's your uncle. So let's jump into it and I'll show you the process of how simple it is to make, for example, a zero clearance insert. This is Tinkercad. It's very simple, but it will give you all the tools that you need to make some basic stuff. And as you can see, this is my zero clearance plate. I've already made this. However, I'm going to show you step by step very quickly how simple it is. Okay, we're going to grab this cube. Before you actually jump into this software, well, you need to take some measurements. I already did, so it's going to be a little bit quicker. First of all, let's sort out the height. I'm just going to click on that box, and the height in my case will be 4 millimeters. Now the size. The length needs to be 254 millimeters, and the width, in my case, gonna be 37 millimeters. Now we need the top layer. Again, same thing. We're gonna start with the cube. This time the height of the cube needs to be 1.5 millimeters, so it is quite thin. The width we're gonna change to 12 millimeters and the length to 254 millimeters. Now I'm just gonna raise this up by 4 millimeters and simply move over our initial base, select both of them, and in the top right corner you do have some alignment tools. Okay, so we need to make sure both of these pieces will be in perfect center of each other. Just click on those black marks and that's it. What we need to do now is to combine both of them. Again, select both, and here we do have a tool for it, the union group. Okay, click on that and check that out. Now we only need one more piece. This time we're gonna go with the transparent box, okay, as we do need to create a channel inside for our blade. This time I'm gonna change the height to 6 millimeters to make sure I cover the whole height. The length will be 10 millimeters shorter, so 244 millimeters, okay, as we do need to have something that combines both of the sides, the left and right, as you can see just over here. How about the width of this? Well, that depends on the curve of your blade. Usually I do tend to use blades that are 3 millimeters wide, so I'm actually going to change this to 3.2 to give me that bit of a wiggle room. Now we need to move this over the base just like that, and again select everything and we're going to align this. Okay, we need to align this to the middle just like so. However, you want to actually align it to one of the edges, to the top or to the bottom. I'm just going to align it through here. And we are almost done. Now select everything again and combine the objects. And there you have it. That's our zero clearance plate insert. How simple was that? However, what I also decide to do is to add a small notch just like this one. Okay, it makes sure that as you are installing this, it's just easier and you do have a consistent separation of the two pieces. So again, grab yourself a box like this one. We're going to change the width to 4 millimeters, depth to 1 millimeter, as it's just a spacer. It doesn't have to be anything else. Okay, 2 millimeters high. We need to be able to actually remove this quite easily without breaking our jig. And simply, I'm just going to align this. Okay, it doesn't matter if it overlaps. It's even better if it does. Select all of it, combine it together, and we do have our tab that we'll have to remove later on. And now simply you need to export this, make sure it's in the STL format, and that's it. We are ready to take it to the slicer. Now, what is a slicer? It's a software that will translate our 3D object into layers that the 3D printer can follow. The next thing you need to consider is what type of filament you want to use. Now, usually PLA is the absolute basic, the cheapest you can get. However, in some occasions it could be a little bit too brittle and it's not very good in higher temperatures. So for example, we do have a spinning blade here. So we want to have some sort of a filament that will work in those harsher conditions a little bit better. That's why on all my projects, all the workshop projects, I'm going to be using PETG filament, PETG for short. It does have better properties than PLA, but still most of the 3D printers on the market should be able to print with it. Sometimes you need to calibrate your printer a little bit more to actually get a good quality print. However, for example, this Elegoo tackles that filament with no problems at all. I'm just gonna press slice the plate, and that's it. We are ready to go. And as you can see, it's going to take about 45 minutes to print and about 26 grams of filament. Now, you do have the option to export this as a G-code, or in my case, I can actually send it straight to my printer as the printer is connected to my local Wi-Fi network. So I can straight away send it to my printer. I've selected the PETG as that's the filament I want to use. It is going to auto level itself. Tell you what, for a beginners friendly printers, I think the Elegoo is definitely right on the top of the list. And that's it. I'm just going to press print and it will send the data to the printer itself. Now it does have some internal storage, so if I do want to repeat this print, I don't have to go back to my PC. I can simply go to the screen on the printer and just from the screen repeat the print. As simple as that. And now I've got 45 minutes of free time. And tell you what, I'm actually going to utilize this free time as the printer is printing to put a sign for my dad together. Okay, he does have an allotment and he does have a shed, and he did have this sign on top of it, but as you can see, it fell apart and it's seen better days. So I'm simply going to clean this up, put everything together, fill the holes with some filler and get it ready for painting. And that's better use of my time rather than making this myself. And there you have it. It's printed off really nicely, identical to the version that I've made from plywood. So let's get this installed in my table saw. As on the plywood version, I'm actually going to be using a double-sided tape from M3. It's very strong and it will do the job absolutely fine. However, if you don't trust your double-sided tape, you can also apply a bit of hot glue if you wanted to, just to make sure it's not going to move. However, in my case, I think the M3 tape will do just fine. Time for the hardest part. Take off that top layer from the tape itself. And now we can attach our new clearance plate. Nice and strong bond. Perfectly flush with the metal insert. And now what we can do, that little bridge here at the end, we can simply cut that out. Now let's test out the fit. Let's see if everything is okay. And look at that, absolutely perfect. Now that's just a zero clearance plate, but actually if you do have a bit cheaper table saw where the plate itself it's not very stable, it's not very robust and it flexes a lot, well, you can design your own plate a lot stronger, a lot stiffer and a lot safer to use and print it off with your 3D printer in no time. Now I do have one more problem I need to solve, this time on my bandsaw. I bet a lot of you that do have bandsaws will come across this problem where the blade, well, sometimes will damage the plate itself, but in my case it's even worse than that. My plate actually splits in half. Check that out. Accidentally I've broke it and I need a new one. Let's design it and print this off. We simply need to replicate this design. I'm going to use my calipers to measure everything around, and from underneath, as you can see, they actually left a lot of free space. In my case, I'm just going to have that as a solid block. We'll make it a little bit more stable. However, I will do those holes as well. Right, with the measurements taken, let's start designing. Again, we're going to start off with the cube. The height needs to be at 5 millimeters. That's the thickness of our plate. The size is 80 millimeters by 80 millimeters. Right, we do have our square, however the original does have rounded off corners. Now what we need to do is to adjust the radius and the steps as well. I know that the radius of the original is 10 millimeters. How do I know that? Grab yourself a square, the piece of the base, put it against it, and then you need to look on the scale where the curve finishes. In my case, it finishes at 10 millimeters, i.e. 1 centimeter. So we need to change the radius to get that rounded edges. But if you change it to 10, then we're more or less gonna get a circle. So what I've found, if you divide the radius by 4, you get the right figure. So in our case, 10 divided by 4 is 2.5. And that should be absolutely perfect. On top of it, you want to increase the steps to more or less maximum, so the corners will be nice and round. Now we need to create the middle slot for the blade itself. Grab the rectangle, height, we'll change it to 5 as the main base, and now the size of it, well, I've measured it and it needs to be 4 millimeters wide and 55 millimeters long. Now we want to cut this out, so we're actually going to change it to hole. Okay, just like that. Now we need to combine both. Okay, I'm just going to put it on top, select both, and we're going to go to the align section. Now we need to make sure it's right on the edge. So I'm going to click it there, and we need to make sure it's right in the middle. As simple as that. Now we're going to combine, union group. And as you can see, we've got a perfect slot for our blade. Now the next thing what we need to do is to create those holes for sawdust. Now the size of them is 5 millimeters by 5 millimeters. The height really doesn't matter as we need to place it on top. In total I need 6 on one side and 6 on the other side. Again, select everything and combine them, and there you have it. Our plate is now designed exactly as the original. Right, let's slice this, and it's going to print for about 33 minutes, and it's going to take about 18-19 grams of filament. And as the printer was doing its thing, I managed to complete this for my dad. It's now ready for painting. However, the printer has completed the job, so let's have a look if that plate now actually fits my charnwood bandsaw. Tell you what, absolutely perfectly, like a glove. The corners are perfectly rounded off and it's flush with the table. The next problem I want to tackle with my 3D printer is the connections between my shop vac hoses, okay? They're all held by some duct tape. It doesn't look great, and to be fair, when I need to take them apart and then duct tape it again, it's just a mess. So instead of designing your own, you can actually go to some websites, for example, Make a World, and type in what you need. In my case, 35mm vacuum hose joint, and there is tons of them, okay? There's so many options that potentially will meet your needs, so you don't have to spend the time on making your own designs. You can actually for free download whatever adapter or whatever you may need in your case, okay? It's as simple as that. Just press download here, make sure to download the STL files, and that's it. Upload it to your slicer, send it to your printer, and Bob's your uncle. So in this case, I've just downloaded files that someone else made, and it's freely available on those websites. Now I'm going to drop a few links to different types of websites just to help you out in searching those items that you want to print. And as you can see, this is going to take about 35 minutes, and it will consume about 13 grams of filament. Now, as I said, this is a normal shop vac hose, 35mm in diameter. So let's have a look if this fits. Yeah, fits like a glove. Look at that. The inside is threaded, hopefully you can see that, and it takes the hose absolutely perfectly. Now the other side, and there you have it. Perfect hose connection, nice and solid and easy to undo as well. And best of all, you didn't even have to spend a minute in designing this. The files are already on the internet for you to download, in most cases for free. Right, and time for the next project. I do have a router table attachment to my table saw. And in this case, this router does have a cable, and it constantly gets in the way when it's not plugged in and in use. And I do have a perfect place for some sort of a hook, a storage idea for this cable. And I already designed it. It took me about 15 minutes to design it in Tinkercad. Check it out. That's my storage solution for the power lead. Of course, it can serve different purposes. You can put multiple cables on it. You know, I think that's going to look quite good. And as you can see, I even got a text in it. Okay, so we're going to be printing in two colors. I'm probably going to have the base as black and the text in, let's say, orange. Okay, so it looks very nice. And you may think to yourself, well, tell you what, that looks very complicated, but trust me, it's not. The only two things I was using, it was the box and this one, the cylinder. Okay, plus the text is actually made by the system itself. Okay, you do have a text option here, and you can type in anything you want. And check this out. That came out really nice with two colors, casual DIY sign, and because it's made from PETG, this is really nice and solid and shouldn't break on you that easily. Right, let's get this mounted. And now I can simply wrap the wire around this in any way I want. Job's done. Simple as that. As you can see, you can create your own solutions to the issues you've got around your workshop in absolutely no time. These printers print really, really quick. In a matter of hours, you can have your projects done and dusted and being used by you in your workshop. But hey, let's create one more project. Alright then, so what is the problem we're going to try to solve? And hopefully you can relate to this as well. You've got your shop vac hose. In my case, I do have my shop vac connected to a wireless switch. So I can just have this remote and switch my shop vac whenever I want. And quite often I work on my workbench. I do have my hose, and as I drill something or sand or anything like that, I do want to quickly switch on my shop vac and just hoover everything out. However, what tends to happen as I put my shop vac on my workbench, well, it tends to slide off. And as you can imagine, it is super annoying. So we're gonna print a hold down for our shop vac that utilizes the holes in my MFT tabletop. And maybe you don't have an MFT style tabletop, but tell you what, you can really create something that will work in your situation to hold that hose in place. There's always a way to design something that will fit your particular needs. And there you have it, our print is now fully completed. Now if you wonder what these notches are, or you probably know already, but basically as you put it in your dock hole, it's easier to lift this up if you do have those notches in there, as you can put your fingers. But most importantly, does it hold the hose? No issues at all, and it's not gonna slide on you. And to be fair, you can position that anywhere you want. And I think that's a brilliant addition, and there is no more running hose from your workbench. Absolutely brilliant and super simple to make. And tell you what, I actually thought about one more thing as I was thinking about the MFT style tabletop and what type of accessory we can make. And this gave me an idea. In most cases, at least in my case, when I try to cut a board on my workbench with a track saw, well, I have to put something sacrificial underneath or some spaces, trying to find some spaces that are equally thick as well, and they move around, and it's sometimes a bit of a mess as I don't want to cut my workbench with the track saw. So tell you what, I came out with a very simple design of spaces that will lift your material from your workbench, and you know, they're sacrificial. If you cut them through, that's fine, you can print another one in no time. So let's get that 3D printer working again. If you're interested in the 3D printer that I have, the Elegoo Centauri Carbon 2, I actually do have a full dedicated video to it with some more details, how to put it together and some initial tests. So if you want to check that out, I'm going to leave a link down below in the description of this video so you can go and have a look. However, if you're watching this video on a TV, I'm just going to put a QR code right on the screen so you can scan it with your phone and save that video to watch later. And if you're thinking about buying a 3D printer like this, then I'm going to drop some links down below as well. Go and have a look. Maybe there will be an offer. It shouldn't cost more than $500 or euros or pounds. So sometimes I've actually seen prices for this particular machine to be at $350. So have a look. Maybe there will be an offer out there. I'm going to try to find it for you, and the links will be down below. And again, another successful print. However, this time it took a little bit longer. All four printed at the same time. It took about 7 hours in total to actually print these. So to be fair, you can just leave it overnight and have these ready on the next morning. But how do they work? Check this out. Absolutely that simple concept. You're just going to utilize the duck holes in your workbench just like so, and now quite easily you can put your material up, is lifted from your workbench. And of course, you know, it all depends what setup you are after. Like so. And now you can place your track, grab your track saw, and you don't have to worry about the blade cutting into your workbench, and you don't have to worry about damaging them with your saw, as well they're just made out of plastic and the saw will go through them with no issues at all. As you can see, 3D printers, well, they're not just a gimmick, and they're not just for printing silly toys for the kids. You can actually create very helpful items around your workshop. For example, like this clearance plate insert, a simple hold down for your shop vac so it doesn't run away on you all the time. And actually you can replace broken items, for example like this clearance plate on my bandsaw. The sky is the limit, and as you can see, you don't need massive skills in designing in 3D software. And best of all, the 3D printing community is huge, and there's so many free files already out there waiting for you. And I think a 3D printer like the Elegoo will pay itself off in no time. But these are just simple designs. There is more to come on my channel. Make sure to subscribe and like this video so you won't miss the future videos. Now the files from the designs I made, they will be available to you to download for absolutely free. Check out the description of this video and get your own. Now at this point I just want to say a massive thank you to my Patreons for the ongoing support. And before you go, check out these two cool playlists. Plenty of fantastic videos for you to watch. For today, that's all. Take care.